proportional relationships. We've been looking at proportional relationships, right?
Yeah.
Especially when we had a proportion which is made up of two what? Equal ratios, right? Yeah. And how did you solve them? Cross multiplied. And you kind of end up a lot of times with something that looked a little like y equals mx plus b. Remember that? But what was the value of b? Usually 0, right? And so it was proportional, right? That mx, that m, was a constant proportional, the constant of proportionality. Yeah? What?
Are they just variables or do they stand for something?
They what?
The M is
They're not the variables, they stand for slope. M is slope, b is the y-intersection.
What's the word it stands for? M is
Slope,
How does that make sense?
doesn't matter,
I said S.
just because S looks like 5s, I guess, and S is also used for distance in physics. I don't know. Anyway, so, and we got stuff that look like this, proportional relationships, k equals y over x, like if you have over pair x comma y, right? Every y was some number of times bigger than x all along the line, right? Okay. Let's look at this example down here, where we have one that's not quite proportional, right? Remember, b equals 0 when it was proportional, didn't it? Okay. I'll write that down. That k up there is k equals the constant, and you'll write it down too, of proportionality. All right. So let's look at this graph here in example 1. It's like a line, yeah?
Yeah.
Okay, it has a y-intercept, it has some kind of slope, right? But they want us to evaluate f of negative 2 and f of 1. Okay, so let's take a look at f of negative 2. What does f of negative 2 equal according to that graph?
This or something. The line with graph.
What number? I want a numerical value for f of negative 2.
1.
So, yep, we go to negative 2 on the x-axis, and the output is negative 1, right? So what is f of 1 equal to? 5, right? Go out to 1 on the x-axis, and you go up to 5. Okay? That stuff we've done quite a few times. So what are the, for f of negative 2, what are the coordinates?
I've been always getting negative 2, comma, negative 1.
And the coordinates here? 1, comma 5. Right? Okay.
I've always been confused about when it gives you the F, yada yada, and then the graph, and then it's like, what is this? And like,
Well, I actually explained it less this time. And
I
you
know,
got
I
it.
can't believe I didn't know that.
Sometimes that happens.
Weird.
All right, calculate the average rate of change between what two x values? So negative 2 to 1, right? So these are the, which one would be the ending input?
Negative or 1.
1 in the beginning input. Okay. What's the ending output?
5.
5 in the ending input.
Negative 1.
Okay, remember it's ending minus beginning output over ending minus beginning input, right? So 5 minus parentheses negative 1 all over what? 1 minus negative 2, right? Which becomes what up top? 5
Plus 1.
plus 1 over 1. So 6 over 3 equals 2. Okay? So the rate of change between those 2 points is 2, isn't it? What else could we call that 2, that rate of change? Thinking of this as a line. We talked about, what is it? The slope, isn't it? That's the constant rate of change, right? Wouldn't that be the m in mx plus b? Okay. Why is that a part A? That's weird. Yeah, probably should be C and D, huh?
Yeah.
Yep. Anyway, is there a proportional relationship between x and y? Right? Well, let's calculate the k for both of these coordinates. What does k equal? Y over x, right? You got x and y here. So if this is a proportional relationship, both of these points should have the same ratio, yeah? The same k? If they don't, then it's not proportional, right? So let's find out. So let's do the negative 2, negative 1. So k will equal negative 1 over negative 2, which is actually what? 1/2, right? And the other point was what? 1, 5? Is that what it was? Yeah. 1, 5. Is it?
It was negative. Yeah.
Wait, why'd you put a negative in B then?
Did I?
One negative or one minus.
Oh, then I sure did, didn't I? Yeah, we better fix that. Why is that like that? Well, 5. No, that's right. Yeah,
Yeah, 5
that's
minus
it. But 1 minus.
negative 2.
That makes sense. No, that'd be right. It'd be
Yeah, that's
5
fine.
minus 1,
Yeah.
not 5 minus
That'd be
negative
horrible.
1.
No, because the ending in
5 minus negative 1. Outputs.
Mhm.
It's these, and then these. Yeah, we're good. I think you're getting confused between the ones, I think. Right, we're good, yeah?
Yeah.
Okay. All right. You scared me for a second there. All right. So k for this would be what over what? I mean 5 over 1, which is actually what? 5. So do they have the same constant proportionality? No. Right? So the k's are different. So are they proportional? So not proportional. Remember, proportional means same ratio, equal ratios. 1/2 and 5 over 1 are not equal ratios, right? 1 to 2 and 5 to 1. Might have something to do with our line having a particular B. Remember, in the couple sections ago, they didn't have a B. They had a 0 for B. All right, so based on your previous coursework, let's see. What relationship does exist between the two variables? You guys kind of touched on it a minute or two ago. What kind of, just in general, would be the relationship? You guys mentioned the slope and all that stuff. Yeah, and does that line have a y-intercept there? It's not 0. Okay, so what relationship do you think this is? Say it again. Well, I gave you a hint. I was talking about m's and b's. Well, what is that function? Do you know anything at all that has an m and a b in it?
And x plus b.
What is it exactly?
X plus b.
Y equals mx.
Y equals mx plus b. So that's the type of relationship our x's and y's have here, don't they? Yeah, and I wrote it down. And what's the m?
Slope.
That's your slope. And what's the b? Y-intercept is where it crosses the y-axis, right? Okay. So the slope in our case is actually what? What is the actual slope? Go up to the graph.
2.
Right. Up to rise of 2. A run of 1. Yeah. So our M is actually 2 over 1, right? But that's just 2, yeah? Okay? And what is the B in this case? Get the graph.
3.
Here we see that the graph crosses the y-axis at 3. So where B equals 3. We have enough to write our equation, don't we? What's the equation that relates?
Y equals 2x plus 3.
So it's y equals 2x plus 3 is the equation of that graph. Okay? Now, kid, yeah? 3 over 1?
The y-intercept.
Yeah.
It's because it'll be over 0 because it's
I write slope this way because, like, slope,
Rise over run.
it's handy to think of it as rise over run, right? And sometimes when you just see 2, you go, what, how's that rise over 1? You can put anything over 1, right? But that's just the value. 3 is just where it hits there. It's not upward. Right? Yes. Your eyes tell me. I don't know what they tell me. What else they want us to do here?
What this equation is
check it for the points from.
Okay, so let's check it for the -2, -1, see if it holds. Okay, what goes in where? What do we put in for the y in this equation? -1 equals 2 times -2 plus 3. Does -1 equal -4 plus 3? I don't know, does it? All right, so it works there. What was the other point? 1, 5? 1, 5. Tell me what to write.
5 equals 2.
Okay, so 5 might equal 2 plus 3. I bet it does. Okay, so both of those points fit in that equation, even though they're not proportional.
Oh, oops. I added 3 to the other, or I subtracted 3 from the other side.
Oh, that's a shame.
I mean, I still
You're-
got the same answer, but.
Well, yeah, you use the added addition property of equality, right?
Mhm.
You add and subtract to both sides, it's fine. Right? You were trying to solve it. We're really doing it, okay? All right, let's go to the other side. And by the way, this M is the slope and the B is the what? Okay. What? It's fine, okay. All right. So you might have heard this term before. That particular equation we just wrote is in a particular form. And the name, pretty easy to remember because it's got what? 2 things in it. So we call this the slope-intercept form of a linear equation, okay? There's other different forms out there that are useful, but this is the one you're most comfortable with, yeah? Okay? And the slope is rise over run, isn't it? And what do we measure in the graph the rise with? What do we measure that with? What values? X's or Y's?
Rise.
Oh, yeah.
Yeah, we measure it with the Y's. And what do we measure the run with? The X's, right? So, like between 2 points, like the difference in how high they are on the y-axis, yeah? Wouldn't it be, you subtract the 2 y values and get that? And for the run, wouldn't you subtract the 2 x values and get that? That's called a difference, right? Okay? So, M is a slope. It's also average rate of change. It is rise over run. Okay? And we get the rise by, has anybody seen this symbol here? And it's not triangle.
No, it's
It's actually a Greek letter.
alpha.
Not alpha.
A.
Nope. This is the Greek letter delta,
Oh, yeah.
which stands for
Delta that.
difference. Difference. Or change in, right? Delta y. Well, if you have 2 y values, how do you find the difference between 2 numbers? How do you
Subtract.
subtract? Didn't we say we just subtract the y's? right? So delta means difference. You get that by subtracting, right? So that's a pretty common thing. Delta y over delta x. That's the same as saying rise over run, isn't it?
I don't know.
Well, what do we measure the rise in? What values?
Y.
Okay. And what do we measure the run in? The difference in the x values of the 2 points, yeah? So delta y over delta x, that's slope, right? Or change in y over change in x. And of course, b is the y-intercept. Are we good with that? Just a new little Greek letter, you know now. I think you know too, because someone said alpha, didn't they? Yeah.
Alpha, beta,
Alpha, beta, and there's
delta,
deltas, and
omega,
omegas, and rhos, and phis, and
We
beta,
have to
Yeah.
learn all of that in school.
beta, and sigma.
omicron.
Yeah, we'll see you. Omicron. Wow. You got the whole
Are you saying
alphabet.
you're not gonna algebra?
But she's going to pass Latin. Okay. All right, so let's go to exercise 2. Here's our linear function. G of x equals 1/2 of x plus 1. So I want us to create a little table of values to graph the function. You what? Okay, good. Well, we're going to do it their way right now, and then you probably did the y-intercept and the slope.
Yeah, I went from the y-intercept and then I went up.
Yeah, that's fine, but we're going to follow their way here. So we want to make a table of values, yeah? X, and then g of x. And do we, unlike in kindergarten, do we need to make like 10 values in here? How many points to find a line?
2.
2. Well, let's see. And usually it's more accurate if you make them like farther apart, yeah? Okay. So how far we can make, maybe -4 and 4? Yeah, no?
5? Make it 5?
Go ahead, you do 5, that's fine.
-4.
I want to use -4 and 4. So I only use 2 points. You can do more if you want. I don't see why you want to waste your time, right? So let's put in a -4 up here. What's half of -4? No, it is not. -2 plus 1.
-1,
-1. Okay, do the 4. What's half of 4?
2,
Plus 1.
3.
Let's plot these. So -1, 2, 3, 4, -1. And then 1, 2, 3, 4, 1, 2, 3. Get your straight edge, or if you don't have one, don't get all worked up over it. Extend it down here a little bit. Oopsie daisy, that's that, maybe. Okay, so all you need is 2 points to graph one, yep. I guess sometimes if you want it to be really super accurate, maybe you put 3 or 4 on there and get your ruler just right, get them all the same way. 2 is technically all you need. So we got B, that's create the graph, okay? All right, what do they want us to do in part C?
Illustrate the slope of the function graphic.
Okay, so just take, any point on here that hits an XY intersection, and then go up and over till you hit the very next one, right? So let's say we were to start here. How far up and over do we have to go to get to, say, the next point where it hits?
Up to 8.
How about up 1 over 2? Now, you're not wrong. You said 4 over 8, right? That's fine, okay. I'm with you on that, right? But when we get done, see if we'll put yours in lowest terms. So this is up 1 over 2, yeah? So our M is equal to what? No, it's rise over run, right? That's our delta y over delta x.
1 over 2.
1 over 2. You said 4 over 8. Would you put
Which
that
is
in?
1 over 2.
Right. So you were correct, right? But you went a little too far up and over. You didn't get like the lowest terms count, right? You didn't go, but it's fine. It'll still work for the lowest terms, okay? Part D, circle the graph's y-intercept. We can handle that, yeah? Wouldn't it be right there? What is that value? What's the value of B?
1.
1. Okay. All right. So you graphed it. Who said they graphed it with that? So she got 2 points by looking at the equation, what's the B here? Hey, that's the y-intercept, yeah? And from there, which way do you proceed to get to the, up 1 over 2, up 1 over 2, right? Or you could go down, -1, -2. Isn't that the same as positive 1/2? -1 over -2? Because negatives cancel, so, okay. All right, let's move on. Now we got another one. Use information about the slope and y-intercept. Now we're going to do it your way, okay? So I want you guys to think about this. We want to graph it, we need 2 points. One of them is the y-intercept, right? Which is what? So B equals 4, and what does the M equal? -3 over 5, okay? So let's have all you guys now graph that line. I'll give you a moment. So we start with our y-intercept of 4. 1, 2, 3, 1, 2, 3, 4. Right? 2, 3, yeah. And this is a negative rise of 3, so down 3. 1, 2, 3, and a positive 5 to the right. 1, 2, 3, 4, 5. And then you take your straight edge. There's your 2 points, defining your line. All right. Extend that out a little bit here. Right? Everybody's graph kind of look like that now?
Yes.
Okay? I mean, this stuff you should have learned before, yeah? Okay?
This was last year.
So you can either graph a linear equation by picking 2 points in the table, or if it is in y equals mx plus b form, slope-intercept form, your 2 points are, the first one is the y-intercept, and then you count your slope of the second point, connect them with a straight edge, yeah? Any questions on this? Okay, now the regions question, we're actually gonna hold until 4.4. Okay, because that belongs there. Which we're gonna do right now. These are really simple. Most of this is review, right? Yeah. So we're gonna go. It is right, but not till I show you one more thing. So